I have no idea what happened. Hey, Noel, I swear I bumped it a little bit with my leg, the computer, and then all my screens went black. But it's not a screen thing because OBS, when it restarted, was just not working. And so, yeah, didn't like that. It's random. But it was C. It is C because since the p-value is high, this means we lack evidence of a difference. So we would conclude there is no evidence of a difference. So it is C. Ooh, now we get into a much bigger problem. I wish this was in the last video. I wish it was. We'll do the full homework right here. Okay, this is a tougher one. And this is usually where people get stuck because they say, how in the world do I do this? Question number 6. Here we go with question number 6. Create a 95% confidence interval for the difference. You know it, you love it. What is going to be required to make this 95% confidence interval? This one is one I get tons of questions on. See my documents are like, see, it's weird. Something happened. Those are the new ones I just opened today. I know, Braden, right? So what do we have to know this?
Notation, brother.
I'll make sure we get all the questions done here. Got just enough time here. What do we need to do? I got to wake up Mubot again. Mubot, did you crash the world, Mubot? Did you do it? Was it you, Mubot? What do we have to know to do this? Because what we're going to have to solve is the following. And you would look at your formula sheet on the test for this. I'm going to do this question here for you and show you how to do it. Notation. You have to know your notation. Does anyone see any of the notation here in this problem? Does anyone see any of the notation? Any of it? The t distribution, any of the notation? Any notation throughout this whole problem? I'll start solving it. Just give me a little bit of notation. Any of the notation? This problem is not bad if you know the notation. It's a real pain. And both sample sizes, I think. So let's go both sample sizes here. Sample size 1, sample size 2. He drives each route 20 days right there. Both sample. So he rides both routes 20 days. And then we have standard deviation of group A is 4. Standard deviation of group B kind of matters, but since they're the same sample size, doesn't matter so much. But just make sure A goes with A, B goes with B. Very importantly, this mean goes here. This is going to be very important. If we mix up these means, we get in big trouble. And then the other mean is over here. And now all we have to find is the t. Great job. So average time each routine. I know this is a classic one, right, Charlie? Good to see Charlie here. Classic. Might have seen my thing. We crashed just a moment ago, Charlie. But this is a classic question. And let's go to the t distribution. We also have the degrees of freedom calculator right here. But with the t distribution, let's go to the t. Mubot, you can tell us where the t is at. He is there. And let's go take a look. So this is the t applet created by Adam Spanbauer. Huge shout outs and congratulations to Adam Spanbauer. Many ways. And family. So if you remember our sample sizes, well, standard deviations were 1 and 4. So sample sizes are 20 and 20. Woo! And there's your degrees of freedom. The degrees of freedom tell you the shape of the t. You have to put in your standard deviation 1, standard deviation 2, sample size, and now we see degrees of freedom are this. I think it copies them. So now we're going to find the t for the interval, and it doesn't copy them. I wish it did. I wish it dynamically changed that. So 21.37 degrees of freedom. The more degrees of freedom it has, the more normal it is. And we're doing 95% confidence. And I have to click between for a confidence interval. The t-score is 1.08. You're probably all right. Let's do 1.077 and make sure. 95% confident means you cover the middle 95% of the interval. So the t is 2. I'll do 08. I'll round it. And square root, plug in your numbers. This is 1. This is 4. This is plus. square, square, 20 over 20. That's 17 over 20, square root, 2.08. That's going to be about 1.9 plus or minus. And then this is 44 minus 42. And it's going to be very close. I get 2 guesses at this. So that's going to make that bigger. 0.9. It's very close to that. We'll solve it here in a second, but the interval, second mean, no. I think I made one mistake. Yeah, no, that's right. Okay. Oh. No, that's where I made the mistake. Because it should be... Okay. I'm doing it in my head. Okay, that's close, but let's find out the 2 decimals. Oh, it's tough with 2 decimals. Let's find out the real answer by solving it for real. Okay. So here's the center. Where's the center of the interval? How do you get the degrees of freedom? Let me show that again, Kaelin. Thank you for asking. To get the degrees of freedom, you have to go over here to calculate Welch's. I'll pause right here and go a little slower. You have to go to calculate Welch's degrees of freedom. Does that make sense? Under calculate Welch's degrees of freedom, you enter in both standard deviations, 1 and 4 for mine, and both sample sizes. And there's the degrees of freedom. Does that make sense, Kaolin? You can also use the same thing over here. We've got Charlie Quick's one, where you enter in sample size, 1 and 4. And then you go calculate, and you'll get the same answer as over here. Let me know if you have questions on that. You then take the degrees of freedom and you need to input it into find t using p-value. Make sure you have your degrees of freedom right there. And all we have to do now is solve for the center. Where is the center of this interval? Where is the center of this interval? We need center and margin of error. Who knows who's watching where the center is? Where is the center of this interval? Where is the center of this interval? The center is the estimate. The center is the estimate. So what do we estimate the difference to be? Well, let me start right there. Where's the center of the interval? Where's the estimate? Take a guess if you don't know. So it's always an estimate, every interval we do, plus or minus a margin of error. So what's the estimate of the difference? I'll get the margin of error while you get the estimate. Oh, and you see it over there. Margin of error being calculated over here. So we go 17 divided by 20. Ooh, great job, Noel. Yeah, you might have it right there. I got really close to the right answer, it looks like. And there's 1.9. And I'm getting slightly different answers, Noel. Okay, I have 1.92. I have 1.92. So I have 2 plus or minus 1.92. So who's right? Oh, Noel, you didn't, you got to multiply the last bit. I see what you did, Noel. The margin of error is everything over here. So this is the margin of error. And the estimate is everything over here. The margin of error is after the plus or minus. Yep. I see what you did. The 2.08 comes from that. You have to times it by the standard error. That last part is the standard error of the difference. And so that's going right there. So 1.92. So we're very close. And then that should be it. Should be it. We did it. And that is because we did 2 plus 1.92, 2 minus 1.92. There you go. Does that make sense on how to solve these numbers? And now it wants to know, what does this mean? If he thinks he can save 5 minutes, is 5 minutes believable? Is a saving of 5 minutes believable? Yes or no? Do you think you can save 5 minutes? The interval is somewhere, no, it's not in the interval. because the interval is estimate of the truth, so it does not contain 5, so we don't think 5 is a true difference. Good stuff. This one is a pain. This one's annoying. And I'm going to show you why I use R. So all this question boils down to is
notation, brother.
Notation. That's all this question is. So what I'm going to do right here is I'm going to open up R and show you why I would use R. And why I'd use ChatGPT. Here is how to ChatGPT and how to R. Okay. We're going to do this right here. This one you tried so many times. Yeah, it is annoying. And it is just flat out annoying. Okay. And I've got longer videos on it. All right. Write a formula inside of R that does the 2 sample t interval where it takes the sample size for both groups, sample means for both groups, and also the standard deviation for both groups. The output is the interval itself. It also has an argument to round it to decimals. We pick. Okay. So this whole question is literally solving this interval again. That's this whole question we're doing right here. I got to mark this in the notes because I only got a few minutes here. This whole question is just doing notation. Now, where do you think people get stuck on this question? What do you think people usually cannot find for their t interval? What do you think people usually cannot find for their t interval? What do you think people get stuck? Because this question doesn't look, other than the decimals, it's not that bad. Where do you think people get stuck? Oh, it just tells you right there. They usually get stuck finding the degrees of freedom. But it tells you the degrees of freedom, which are the shape of the t. So answer this for 5,000 points. What is my t statistic for 90% confident with 132 degrees of freedom? What is my t statistic for 100 or 90% confidence with 133-ish degrees of freedom? What is my t statistic? Because you need that to solve the interval. So what is my t statistic? All you're doing is taking all that notation right there and plugging it into this. All you're doing is taking that notation over there. Let the zoom out a little bit. Yep, sounds about right. Yep. So does everyone understand? And then there's one last trick to it too. So, and what people did is they went to the t-applet. It's 133 basically, for all intents and purposes. And you go here, you put in 133, you put in 90% confidence, and there's the answer right there, 1.656, or it might be a 7. And then I guess because it was something like this, sure. Does that make sense? 1.66, 1.656, close enough. And you will use this number in the formula where the t is at. So remember, the t is based on the degrees of freedom to tell you the shape, and we just did the last problem where we had to find the degrees of freedom. This one told us it. So actually, we know all the values. We know mean 1, mean 2. Now be careful. It says to set up your interval, it should say in here, let waterfront be group 1. So your difference is going to be positive or negative. So answer positive or negative in the chat. Your difference between the means, because it says let waterfront be group 1. So this mean would go where? And is the difference going to be positive or negative? This mean would go where? Because that's one of the means. It has to go here somewhere. Where would this mean go? It says let it be mean 1, which is the first one. So you're going to get like 300,000 minus 200,000. The difference is going to be, it'll actually be the pink one. Because it says let waterfront be group 1 and non-waterfront be group 2. So it's saying waterfront, it reverses the order, and that's usually what gets people to. It's ridiculous that it does that, but you will get if your values look this way, you will get a positive difference. Does that make sense? because this mean goes here and this mean goes here because it says waterfront is group 1, non-waterfront is group 2. The T was 1.656 found via the applet. Standard deviation for group 2, this one doesn't matter. As long as you put S over the right N, you're good. As long as you put S over the right N. Doesn't matter if you mix those up, but you have to have S over the right N. So it'd be 190,000 over 102, 161,000 over 80, and you've got a lot of decimals to carry. This is why it's really a lot better if you can use a program for this or something, because you can see, watch this, we're gonna go open RStudio now, remind me later, and plus R script, okay. So we've got our screenshot, let's go to ChatGPT, and there's the work for it. And there it is right there. Here's all the calculations. Nice and easy. It's even doing the degrees of freedom formula for us, the 2 sample. Oh, it's asking us if it's pooled or not pooled. Calculate pooled standard error, calculate degrees of freedom using... Oh, Welch's. It's doing a pooled? Yeah, wait. Square root of standard deviation 1 squared over n1 plus... Okay, yeah, we're doing the pooled. Does this make sense? If you've been following along all today, check it out. There's your formula. The square root of standard deviation 1 squared over n1 plus the square root of standard deviation 2 squared over n1. Now it's doing it based on a 95% confidence interval. That's because 2.5 would be neither tail. There we go. It's two-tailed. It even tells us that. Calculate the margin of error. So there's the margin of error. T times the standard error. Calculate the difference right here. The lower bound is the mean, the difference minus the margin of error. The upper bound's this. Round it to a certain amount. And here's an example of the output. So what we should be able to do is we should be able to take this and bring this over here and just put in our values. Really, I want to make the screen smaller. Here we go. And I wish we had it looking like this. All this is doing for me is plugging values into a formula. Okay. Bring this over here. Sample size of group 1. Group 1 is the waterfront. Remember, when you're doing this, subtract with waterfront first. 80, and then mean is going to be 341,05087. Standard deviation of this group is 161,595.51. You probably could just ask ChatGPT the answer to this one too. You could say, here's my, it would probably just solve it for you anyways. I mean, you should know what you're doing right here. You should know the formula. You should know the theory behind this, what you're trying to solve, the true difference between these groups. But there's ways to get answers, and we do allow you to use technology on your homeworks and quizzes. So, and did I evaluate the function? It looks like I didn't from the environment. And there it is. And there's the output. Let's see what it evaluated to. There's the interval. All this is doing is solving a bunch of things for me, solving a bunch of the math. Round to the nearest whole number, so 8. And then we go over here, grab this number, that'll round up also. And we should just round to 0 decimals. Could have done that. Check answer, and oh no, ChatGPT, what'd you do to us? What'd you do? What happened? 20,000 points if you see it. 20,000 points if you see it. 20,000 points if you see it. I'm going to grab my protein bar of the day. 20,000 points if you see it. Who sees it? Grab the red protein bar. Does anyone see it? Oh. Chocolate brownie. No one sees it? We did everything right, except should be 90% confident. Now this is 95% confidence interval. So what we can do right here is put it to this, and the two-tailed would be 90% confident. And then when we run this right here, we can even do decimals. Oh, why does that decimal say 102? Decimals 0. There we go. Should have been 90% confident for the interval. And there it is. So it's supposed to be 90% confident. So because we did the wrong level of confidence, we got the wrong interval. That's the 95% confidence interval. And this is the... And I'll put a... I do this slower. I'll put a link to this one. So there's the right interval right there. Let me go grab... This is waterfront property. So if you are looking for a slower walkthrough of this, I just love showing that tech can be done with it too. Let's go find the waterfront property one. Waterfront property, okay. Waterfront? What's it? I thought we had this. We've done this one a billion times. A random sample took. A random sample, chapter 17. Surely I've done this one before. This is a good random sample. What? It's not in this one. Here we go. Hour 10 minutes. What? I've done the waterfront. I know I have. Chapter 16, 17. 4 years ago. That's a long video. Review online officers. 4 years ago. Man. What the? Here we go. What? I don't know. Last try. You about target away right there. Surely I did in this one. What the world? Okay, this looks good. Sun pop popcorn kernels. What in the world? I know I've done it. Well, I'll have to find it. If you're stuck on it, let me know. Oh no, it's not finding waterfront here. No description. Didn't add labels on. Oh, that's old homework. 7 months ago. Okay, last try. Where's that shirt? I don't know. I haven't worn that shirt in a while. Yeah, let me find it. God, no, I gotta head on a moment. Post on Discord about it if you want. I've done this question so many times. No, that's the way it used to look a long time ago. May 3rd is a big one. Yeah, I've never done this question. It's gonna be on February. You gotta look for end of the semester. Substrate type. What is that? Okay, last one. Because I gotta. May 5th, evening. Well, we'll find it. Till next time. Bye for now. Bye.